So what I want to do is go over, for the, like I said, 100th time, this average rate of change concept. And we're going to extend it to one more type of idea today. Okay, so AROC, average range of change, is the change in Y over the change in X. This is the new part, and I'll talk about that in a second. There's that formula we've been doing over and over and over. That's a formula you need to know. It's not going to be given to you, but it's just the slope formula. So I think you guys know it after doing it for so many days too. Okay, so if you look at a curve, if we have 2 points on that curve, what we are finding when we do AROC is the change in Y over the change in X, which is slope, right? Rise over run between those 2 points. So that slope that we've been getting, or AROC, is the slope of this line that you could connect the 2 points with. So what this line is a secant line, okay? So that line that connects 2 points on a curve is called a secant line. And that's where this new symbol comes in. We're just extending the idea. What we're really finding is not just AROC or slope, change in Y and change of X. Specifically, it's the slope of the secant line, okay? So, and we're going to talk about that here more on our second of 2 examples. In this first example, this is going to almost insult your intelligence, okay? You're going to probably be like, why is she even asking us to do this? And the first 4 homework problems, same thing. Like, really simple, but super important. So I got to catch you early if you don't understand this stuff. So here we have, let me read. Consider the graph at the right. It passes through these 2 points, 0, -3, and 4, 3. Okay? Those are the 2 points the graph passes through. Okay? Now the question is, explain how we know that the equation of that line is this. Okay, well maybe we don't know, but let's talk about it. So I think you guys know that that's slope-intercept form, right? And your M is your slope, and your B is what? Is your y-intercept. Good. Yeah, feel free just to see. Okay. And then, so in this case, we have a slope of 3/2 and a B of -3. So a couple things, again, insulting your intelligence a little bit. You don't have, you always want a fraction or a whole number. So we wouldn't use 1.5 for a slope, okay, so fraction. And if it were a whole number like 3, you could make it a fraction just by putting a 1 under it, okay, because we need 2 numbers for slope, rise over run. And then for your y-intercept, don't forget if there's a minus in front of a number, it becomes a negative when we pull it out, okay? So y-intercept of -3, and we can look at this graph and confirm the slope is 3/2 by doing rise over run. So if you count this, this goes up, how many does this go up? I can't see. 1, 2, 3, 4, 5. It goes up 6, right 4, and 6/4 reduces to 3/2. Okay, so that's where they're getting it. Is there anybody that has a question about anything I just said? Okay. Not trying to trick you. This is really important that you know that. And this next idea is really important too, this last little part here. What do you notice about the AROC, which we normally just call slope, but we can call it the AROC. What do we know about the slope or the average rate of change of this line or any line? What do we know about it? Okay, this, I heard someone say positive increasing. Wonderful. I think I worded the question right. Wrong. This is a increasing. That means it's got a positive slope. Yes, but I mean any line in the world. So it could be negative and decreasing and all that stuff. So but what do we know about a linear function and its slope? What do we know? It's the same. It's constant, right? On a line, no matter what 2 points I pick, the slope will always be 3/2. It can be a mile that way and 17 miles that way, and we pick 2 points. It'll be huge numbers, rise over run, but it'll always reduce down to 3/2, okay? So the slope is constant on a line, okay? That's not the case on a curve. If I choose to pick like this point and find the slope of the secant line that connects those 2 points, it certainly isn't going to be whatever this one is, because right away we know this slope was going to be positive, this slope would be negative. So on a curve, any 2 points, it can change, okay? On a line, it won't. Okay, good on that? All right, I'm sorry, this section gave me extra gray hair, and I'm not kidding, it's time to color, because I'm getting all gray right here because I'm so, this section, I swear, I've been working on 1.3 for like 3 days, I'm not even kidding. I just don't like how it's set up. So what you're going to do is turn the page for 5 years, spend about 5 years finding the next page. You want to go all the way to example 7. Example 7 might even be in day 2. The page we just wrote on and this page are the only 2 pages in section 3 we're going to be using, besides the homework, okay, the practice sets. So later, don't do it now, but if you want to throw away the pages in between, you can, or just leave them there, whatever. But this is the only other example. Tomorrow we are going to do a day 2, but I'm doing my own thing. I'm going rogue. I'm going to do my own thing, not use her stuff. Okay, we'll worry about that then. Now, here we have another problem. We have the graph, and we have the equation, kind of like we just did with the line. The difference is it's a curve, okay? So let's look at the first part. Given this formula, negative x squared plus 4x plus 1, we probably know a little bit about this, right? X squared is a parabola. Since its a value is negative, it's opening down. So here's a picture of that algebraic equation. So what they want us to do is find the AROC of G, this is G, from -1 to 3. Nobody in first period could tell me what -1 to 3 meant. What is that? Somebody tell me. What is from -1 to 3? In your own words. What is it, Nicole? They are the, it's not, and it's, yeah, it is interval notation. It's, you all are right. Sorry, Nicole. I've got tongue-tied. It's saying from -1 to 3. But the most important thing I want you guys to understand is it's the x's, okay? What are they talking about? Let me show you on the picture. I want you guys to see a visual because I still feel like there's people that don't get what this means. So on the x-axis, -1 is right here, right? And 3 is right here. So what's confusing, I think, because I get it, is I'm talking about what's happening on this portion of the graph, but not on the x-axis. The graph is only on the x-axis right here. So I'm talking about from where, where the graph hits, probably here. So it actually starts here, where -4 is. This is x is -4 at this point, right? X is -4 at this point, and then it goes up all the way to when x is. Right. So it's really that piece of the x-axis is zeroing in on that piece of the graph. It looks weird, but that's what you're thinking of. So the question is, what's happening on that part of the graph? We're going to find the average rate of change. It's an average. It's not going to be perfect. If I picked, by the way, 2 that were closer together on that same interval within -1 and 3, like I just zoomed in on these 2 or something, I would get a different answer. So you could get lots of different answers. They're asking specific. It's average. It's an estimation. Okay? So let's go ahead and use our formula for the 100th time. And you can be calling it slope, m sub secant, like the secant line. There's so many different ways you're going to see it. I've seen some people just write ROC for rate of change. Okay, so just know what you're doing and then it doesn't bother you. So I'm going to find the AROC, and I need the ordered pairs. So I know what the x values are of my ordered pairs, right? Remember, those are x's. And I can use the graph, or I can plug in. I'm going to use the graph. Less work. So -1, 1, 2, 3, 4. So -1, -4 is our first point. And then 3, is that 4? Yes? Yeah, okay. 3, 4. Good. Got our 2 points. And we plug into the formula. Remember, the order doesn't matter as long as you put y's on top and then you follow that order. Where'd my negatives go? Because you can skip that step if you're comfortable. You don't have to skip the step if you don't want to. But 4 minus -4 is +4. Okay? I don't care if you skip that step. 3 minus negative 1 is 3 plus 1. We get 8 over 4, or 2. So what we just found, and I'm mark it wrong if you didn't write it like this, but I want to make a point. The slope of the secant line is 2, also known as AROC, rock, changing y over changing x. So many different ways you can call it. Okay, so we just did part A. I want to skip to part C first before I do B. And it's asking us to sketch the secant line on the graph at the right. Remember, I just introduced you to that term. We want to connect these 2 points with a line. It doesn't have to be perfect. Yes, Aaliyah? 4 minus negative 4. Okay, 4 minus a negative. Those 2 negatives cancel out. 3 minus a negative, those cancel out. If you need to write it like that, that's fine. You should still get 2. Okay? All right, so those points, let's just really make sure we know where they are. So I have this 3, 4. There's a point there, and then the negative 1, negative 4 is here, right? So all you're going to do, and you can use the edge of your calculator. You don't have to make it perfect. A little trick for connecting them is just to connect this, make it a segment, and then you can extend off of it. It kind of helps you make a straight line without having to get a ruler out or anything like that. It's a sketch, guys. The word sketch means it doesn't have to be perfect, okay? So we found the slope, and we just sketched the secant line that connects those 2 points. And so what the last thing we're going to do is write the equation of the line, the secant line. We are going to write that equation in slope-intercept form. So I want to make sure you guys understand this notation. It looks scary, but look at it a little closer. It's saying find an equation of the secant line containing the points. This is another way of writing this, right? Look, there's my x's that I started with over there. G of negative 1, that means what is y when x is negative 1? And we already did that. We went x is negative 1, y is negative 4. That means the same thing. You really have to learn that that notation means just y value when x is negative 1. And then, of course, this number is 4. So it's just repeating the same thing it said up there, just written in another way, which I like. I like you guys to see lots of different representations so you feel comfortable no matter what you see. Okay, so we already know the slope, right? So we know the slope is 2. And we have to write an equation in slope-intercept form, so we need an m and a b. Well, we don't have a b. Well, you might, because we have a graph, but we're not using the graph because we sketched it. You're going to show it algebraically. So let me reintroduce you to your old friend. This is point-slope form. So one there. Okay? So this is point-slope form. It's named that for a good reason. It's got a point and a slope in it. Okay? This is going to be a number, and this is going to be a number. X sub 1 and X sub y, that's where you're going to put a point, an ordered pair, an X and a Y. And of course, we know M is your slope. So this is how we're going to get our equation of the line. We're going to plug a point into X sub 1 and Y sub 1, plug our slope in, and then rearrange the equation into slope-intercept form. This is literally something you did in Algebra 1 and maybe Algebra 2, okay? And when I say that, just so you know, I'm not trying to insult you like you should know how to do this, because you might be like, I don't remember doing that. It was 100 years ago, okay? I don't remember what I had for breakfast today. So I'm not saying it to be insulting, just so you know. I say it just because some of you might be like, I feel like I've done this before, or this is really easy. That's why I'm saying it, just so you know, okay? All right, so let's go and pick a point. What does she mean, pick a point? Literally, you can pick any point you want on this whole entire line. We're not going to use the graph because we sketched, like I said, but we have 2 choices right here. Pick which one you want. It doesn't matter. I'm going to use the harder one just to prove a point to you. If you want to do this with me and maybe use the easier point so you can prove to yourself that we get the same answer in the end, go right ahead. But since Aaliyah asked that question with the negatives up here, I'm going to use this point. So this would be my X sub 1 and my Y sub 1. Okay, I picked this point. You can pick that one. And then there's a slope. And I'm going to plug right into point slope form. So it's y minus, right? Y minus negative 1. Y minus negative 4. Sorry, that's my Y value. Equals M parentheses X minus, I'm just following the formula, X sub 1. Which is negative 1. Aaliyah, do you get what I did there, sweetie? Okay. Yeah. All right. And then, by the way, if you chose this point and you're like, why is she writing all those symbols? You don't have to. You could have gone right to making that a plus sign like I did up here. I don't need to see this step. I just wanted to make sure she and anybody else understood it. Okay. So what we really have is y plus 4 equals 2 times x plus 1. So the two minuses or negatives cancel out. That's point slope form. But we are going to use slope intercept form. So we're going to distribute the 2, isolate the y. Okay? So I'm just going to go up here. When I distribute the 2, so I have y plus 4 on the left-hand side, 2x plus 2. When I distribute, what's the last step? Go. Subtract 4. Do you have to show the step? Not for me. You don't have to show it for me. I'm just showing it for anyone that might get lost here at the beginning. With equation solving, you can combine steps in your head and stuff if you want to. I don't need to see every single step. So what we just found is the equation of my green line there. And it looks about right. I almost hit the -2 perfectly when I sketched my graph, but you can see I'm a little above this point. That's why it's a sketch. It's not a big deal. But it makes sense. I could estimate the slope as being 2. It's almost hitting perfectly on my B, which is my y-intercept. Okay. So finding the rate of change the same way we've been doing, then using that information and putting into point slope form. Either point, it doesn't matter. Did anybody do 3, 4, by the way? You did? Did you get the same answer as me? Are you sure? Okay, yeah. Anybody else? So if you did 3, 4 and you didn't get the same answer as me, when I come around, tell me, okay? And I will see what you did wrong, because it has to be something you did wrong. Okay, that's it. That's all we're doing. So let me explain what the homework is. More flipping. This is what you guys are going to learn today, why it's so important to have your binder organized, because it's so much flipping. It's one thing I do hate about this. Okay, so on your 1.3 day 1 worksheet, functions, practice that one. And you don't have to put your name on it. Okay? You're never turning it in. It's staying in your binder. So if you don't want to waste time with all that stuff, that's fine. But if you want to, you can. So go ahead and write that down. And when I talk about 1 through 8 all and just the first part of 1 through 4, you can just go and cross these out. We're just doing 1 through 4, which is pulling the slope off of a line. Rise over run. What's the slope? That's all you're doing for 1 through 4. You see? Okay. And then on the bottom, I wrote out all the work for these on a separate paper, so I'll put that up in a second. This is exactly what we just did, and there's 4 of them. And I'm going to do the first one with you right now. I'm going to do number 5 with you right now to get your homework going. But this is just given 2 points, find the secant line that connects those 2 points on the curve. Okay, so let's do number 5, which is just like the problem we just did in the notes, to make sure you guys truly understand, okay? And just real quick, all you're doing with these is the slope. Pick 2 points, do your rise over run, so this was 4 over 2, and I simplified it. A-rock, slope, whatever you want to call it, is 2. That's literally all you're doing here, okay? But don't do it now. That's going to take you 2 seconds to do. Let's do the harder one. Not that it's hard. Let's do 5 together. We're still on homework. If you write small enough, you can probably fit it in that little box. You all know me by now that I don't write very small. Okay. So we're on to the homework here. It's giving us the interval of x's, and we have to find the A-rock and then the equation. Just like what we did. The only difference is we don't have a graph. We don't have a graph. So to find these ordered pairs, I have to do what? How do I find the y's if I have the x's? Plug them in. That's exactly right. Plug them in. And you can use your calculator. You don't even have to show any work. So if I plug in -2 for x right there. I'm going to pick my calculator up and go 5 divided by 2 times -2 minus 4. And I should get -9. I started with my calculator. No work to show. 5 divided by 2, there's my 5 halves, times, or you could use parentheses, 4, that's the x value, minus 4. And I get 6. Doesn't get much easier than that. Alright, so why'd we do that? So we can plug it into our AROC formula. 6 minus -9 would become +9. 4 minus -2 would become +2. And here's how you would just simplify that on your calculator. 15 divided by 6, enter. And we, like I said earlier, did I say it in this class? I don't know. You would never have a slope that's a decimal. So we hit math, enter, enter. And then you can see it simplified it for us, 5 halves. So that's the slope. Now we're going to use our point slope form. I'll write it again for you if you need me to. Try to help you so you don't have to flip around so much. So we're going to plug right into this equation. Which point do I have to use? Trick question. Which point do I have to use? I don't have to use anyone. I can use either one that I want. Okay? I like non-negatives. I like positives. So I'm going to use that one. So I'm going to do y. I'm using this point right here. Y minus 6 equals 5 halves. That's my slope. X minus 4. That's point slope form. Then we will distribute 5 divided by 2, so there's my 5 halves, times -4. That's what that says. 5 halves times -4 gives me -10. And of course, get y by itself, add like terms, go over here. That's our answer. That's right. Does it look, does anybody see something that looks a little strange? The same thing, right? Why? Because the equation of the line of the slope is the same the whole way. So they're going to always match up. If this is linear, which it was, your answer is going to be linear and it's going to be identical twins. So there's a little kind of trick to know. I would want to see the algebraic part of it. But if you're given a linear and you find its slope and plug it back into the formula, it's going to be the same thing. Now 6, 7, and 8 are quadratic, so x to the second, so it won't happen like that. But I do have all the work done for you. Okay, and I'm going to put the answers to 2, 3. Oh wait, I did one, I think. Yeah. Thank you for waiting, Nicole. So there is the answers to 2, 3, and 4, so I don't have to flip around. And I will move it up for 8 in a minute or so. But if you didn't finish writing 5, 5 is all right there. Okay. All right. So I'm going to be checking. This is how I do it. A6, and I'm a Post-it note fool. I mean, I go through so many Post-it notes, as you guys already probably know. So I'm going to be checking A6 and A7. Take 5 seconds right now. Find them, put a Post-it note on it, and then go right back to work. Don't wait for me. Don't just sit. It'll take me forever to get to you probably. So just keep working. Let me just show on camera what 8 is in case someone's watching this. Okay, there's 8.